This chapter 5 is the first one about experiments. In this chapter, you will learn the basic terms and concepts used in experiments, and you will learn about well-designed experiments and badly designed experiments. I will start with a reminder of something you already know. In observational studies, a researcher just observes people. He or she does not attempt to change any behavior or to interfere in the social life he or she is watching. But in experiments, the researcher is deliberately imposing a treatment to the subjects. So he or she wants to know if this treatment will have an impact on the response. Treatments in medical science are generally medications or vaccination, but treatments in social science can be anything. It can be a lot of things. It can be watching documentaries to know if it will change your political opinion. It can be playing video games to see if it will make you more aggressive or smarter. It can be exercising to see if it will reduce your stress level. It can be avoiding your cell phone for a week. It can be taking certain drugs or alcohol. It can be watching porn. It can be being exposed on purpose to certain situations. It can be anything. Well, it can be anything as long as it is ethical, but we'll see ethics later on. In experiments, as in other research methods as well, this is not only in experiments, but I introduce these concepts in the chapter on experiments. There are many kinds of variables. Basically, two kinds of variables to start with. You know what a variable is. You have learned that in chapter 1. A variable is something that describes a subject. It can be the stress level, it can be the aggressivity, it can be the political opinion. It can be your height, your eye color, your salary, your gender. It can be a lot of things that describe you are variables. Sometimes variables are correlated. There is a correlation, a relationship between two variables that describes you as a subject. It can be your gender and your income. It can be correlated. Maybe men earn more than women in a society. It can be your height and your talent as a basketball player. Variables are sometimes correlated in subjects and sometimes not. When we try to study the correlation between two variables, we consider one as the explanatory variable, also called the independent variable. It's the one that will affect the other one. And the second variable is called the response variable, also called the dependent variable. It's the variable that is affected. Example, if I find a correlation between your gender and your income, gender here is the explanatory variable, and income is the response variable. And the gender explains the amount of the annual income here. So income depends on gender. If I want to know the correlation between procrastination and academic performance, I think that procrastinating will affect academic performance, will lower it. So here, procrastination will be my explanatory variable. It explains the academic success, and the academic success will be my response variable. It depends on procrastinating or not to a certain extent. So in a set of two variables that can be correlated, there is always one that is the explanatory variable and one that is the response variable. Well, in fact, not always, but we will see it like that for this chapter. In experiments, the explanatory variable is the one you manipulate, is called the treatment. I come back to my example, does procrastination affect academic performance? Here, the fact that you procrastinate or not will explain how well you do academically. So the explanatory variable is if you procrastinate or not, and the response variable will be your academic performance. If I take another one, does playing violent video games will increase the level of aggressivity in students? So here the explanatory variable will be to what extent you play violent video games, and the response variable will be your level of aggressivity. When we do an experiment, our precise goal is to figure out if the explanatory variable has an effect on the response variable. And we even go further. With experimentation, we try to find if there is not only a correlation between the two variables, but also if there is a causation between the two variables. We can try to find if A causes B, if procrastinating will cause you to perform badly academically, or if playing a lot of video games that are violent will cause aggressiveness in subjects. Two additional concepts to know. Subjects, you know what it means already. Those studied in any study, in this case here in an experiment. And a treatment is the condition you impose to your subjects. And as I said, in social science, it can be a lot of different things as long as it is considered ethical. There is a third kind of variable that we want to avoid in social science. They're not only present in experimentation, they're present in any kind of research, and they are lurking variables. Lurking variables are those variables that have an impact on the results of a study, on the response variable, but they're not the explanatory variable being studied. And we like experiments because they're good at eliminating possible lurking variables. Especially in lab experiments, we control the environment in which the research is done really well. So this will allow the elimination of most lurking variables. And when I talk about lab experiments in social science, I'm not talking about experiments taking place in the lab. I'm talking about experiments that take place in a controlled environment. This is why we can say that when doing an experiment, we can claim there is a causation between two variables. Variable A will cause variable B in a subject. So what you have to remember in this slide, lurking variables are those who have an impact, will influence, will affect the response variable, but they're not the explanatory variable. There's something else, a third variable around. If I come back to my same example, does procrastination affect academic performance? Maybe yes, maybe no. Here, the explanatory variable is procrastination. The response variable is academic performance. So lurking variables here are variables that will affect academic performance, but they're not procrastination. There's something else. It can be how well a subject is able to study. It can be how well a subject sleeps before a test, the level of stress, the interest of the subject for the material being studied, or the general skills the subject has. So there's a lot of things that can affect academic performance that are not procrastination. And these things are considered lurking variables. Another concept present in social science research in general and in experiment, and we use it a lot in experiments, is the placebo. A placebo is a fake treatment given to a subject, and you will learn why giving placebos is so important in research in general. So a placebo is a fake treatment. It's a sugar pill. The placebo effect happens when the subject responds to the placebo, receives a fake treatment, and it affects the response variable in this subject. A good example of that is this guy in, I don't know if you watched the show Big Bang Theory, but Raj in the first seasons could not talk to women, unlike he takes alcohol. He was not able to talk, to speak to women. And in one episode, he was drinking non-alcoholic beer and he was talking to ladies, no problem. This was a placebo effect going on here. Now we'll talk about different ways to design experiments. And I will start with a real life example that happened recently in the medical community. It is a medical study, an experiment done by a famous French microbiologist. His name is Didier Raoult. And this experiment, this research was rejected by the scientific community, and I will explain why. The study goes like this. They used 80 subjects. Everyone was positive for COVID-19, and they were all treated with a combination of two medications. Hydroxychloroquine, which is a well-known medication against malaria, and azithromycin, which is an antibiotic. So all subjects were given both medications. And they were probably randomly selected. Only one subject died from the disease, and the 80 subjects were already sick when the study started. 79 of them recovered, so it was a very low death rate of 1.25%. So the researchers claimed that the treatment is a success and that all patients who have COVID-19 should be treated with these two medications. So this study was not accepted because it was a one-track experiment in which the same treatment was given to all subjects. So there's no way to know the treatment really worked because we don't have any similar subjects to compare to. So we don't know, maybe that without the medication, still 79 subjects would have recovered anyways, because maybe they were healthier, they were younger, or by coincidence. I will give you a similar example. Suppose that I want to know if coffee will help my methods students staying awake and alert during a methods lecture. So I decide to give everyone a double shot espresso. I have 25 students, so I will give everyone the same treatment, espresso. After receiving the treatment, I noticed that all my subjects are super alert, they're taking notes, they're asking questions, they're not distracted, they pay attention, it's awesome. So I claim, oh my goodness, coffee works. I will always give coffee to my students. Can I really claim that? Absolutely not. Maybe my students act like that because I'm the best teacher of the world, not because of coffee. To know if coffee really works, I would need what we call a control group, a similar group of 25 students who will not receive coffee, who will not receive a treatment, or who will receive a placebo decaf coffee. And this is what was missing in the hydroxychloroquine experiment, a control group receiving a sugar pill instead of the real treatment. So with a control group, I can do a comparison between my groups, and I can be sure that yes, the treatment works, or no, the treatment does not work. A control group is a group of subjects, ideally identical to the other group. It's a control group that receives a fake treatment. So a sugar pill instead of a real medication, or decaf espresso instead of real coffee, or any other fake treatment. So in a well-designed experiment, I have two kinds of groups. The first kind is the experimental group. This is the group, or maybe the group, sometimes there are many, that receive the treatment. and there is the control group. This is the group as similar as possible in composition, but that does not receive the treatment, or that receive a fake treatment, a placebo. A very simple but very good way to design experiments is what we call randomized comparative experiments. This is where you compare an experimental group, or 2 or 3, depending on how many treatments you want to give, and a control group. This is a very simple example. Suppose that I want to know if having a practice exam will help my students doing better in the final exam. So I will separate my class into groups, and very important, I will randomly assign students to one or the other of the groups. I will not put all girls in one group and all men in my other group, because it will create a lurking variable maybe. So I will randomly assign students to each group, hoping that this random assignment will make my 2 groups as similar as possible. To one group, I will give a treatment. This is the pink line on the bottom. The practice exam here is the treatment. It's my experimental group. And to my other group, the one on top in blue, I will give no practice exam. They don't receive any treatment here. And then I will compare the outcome. I will compare the results in the final exam. And maybe my group receiving the practice exam will do better than the other one, or maybe not. If I want to claim that my treatment works, hydroxychloroquine, or a practice exam, I need a big difference in outcome between my experimental group receiving the treatment and my control group not receiving a treatment or receiving a placebo. If in the COVID example, all patients on hydroxychloroquine recover and many patients on the sugar pill do not recover, well, I will assume the treatment works because there is a major difference between my 2 groups. But if I have the same outcome in both groups, or a very similar outcome in both groups, I would say that my treatment does not work here. So when there is a big difference between the 2 groups, you can say that your treatment works. You can say that the difference is statistically significant. Ideally, in a randomized comparative design, both groups, my experimental group and my control group, are identical in every way. This is why I do a random assignment to each. So I know that any difference in outcome between my 2 groups is due to the explanatory variable, the treatment, not due to any other lurking variable. And as I said, to be confident that my treatment, my explanatory variable, does work, the difference in outcome between my experimental group and my control group must be large. And there I can claim statistical significance. It means that the difference between my 2 groups is so large that it would not happen by coincidence. It is really due to the treatment. Sometimes in science or in social science, we can't conduct experiments because it would be too dangerous or unethical. Some things cannot be measured experimentally. One example, we all suspect that texting while driving will cause accidents because there's a strong correlation and we can assume that one causes the other. To be sure, we would have to conduct an experiment, but we can't do that. I can separate my class in 2 randomly assigned groups of 14 students and say half of the group is driving to Montreal without a cell phone, and the other half is driving to Montreal with their cell phone, texting all the way. Good luck. Let's see who's going to make it alive. I'm not going to do that. It's unethical. So in this case, There will be other kinds of experiments that are less dangerous. We will learn them in methods 2, or just observational studies will be better ways than experiment. I will study maybe medical records of people who died in car crash and see how many of them were due, with the percentage of them that were due to texting or to any other factors. This would be considered an observational study here.